Hello and welcome back to Ganesh Institute channel. So in today's video we are going to discuss the derivation of three equations of motion using calculus method. I hope you have already watched another video where we discussed about graphical derivation. So let's begin. Firstly, let me tell you what is calculus method. So as we have discussed that these are the three equations of motion, right? Where some notions like velocity, final velocity, initial velocity, acceleration, time, displacement have some relations with each other, and these are our three equations, right? Now we discussed how we can derive them using graphical method. But when it comes to calculus method, we have two methods in it. One is differentiation and another one is integration. So, if you talk about differentiation, let's say you have to find out, basically this is sigmoid curve and dx, this is a representation of integration, the symbol of integration, and this is the symbol of differentiation. So basically you can say that in differentiation we divide, and when there is a multiplication then we do integration. And we have some function here. But remember, this function should be in the form of x only, and if you are taking differentiation of something with respect to x, that means it should also have the function in the form of x only. So if you have to find out integration of x raised to power n, then the formula would be you have to increase 1 in the power and divide it with the same power. Whereas if you have to differentiate x raised to power n with respect to x, then what you need to do, you have to bring this in the form of coefficient, and you have to reduce one power from the exponent. So if you, let me give you an example. If you have to find out integration of x cube, then it would be you have to increase 1 in the power and divide with the same power. Okay. Whereas if you have to find out differentiation of x cube, this is also the representation of differentiation when you use prime. Now you have got n, that means the power in coefficient, and reduce 1 in the power. So where do you use them? Let's say you have a function x in terms of t. This is your displacement, and it is given to you that you have to find out the velocity at time 0 and acceleration at time 0. So how you will find out? You will see that displacement is given to you. That means your velocity will be, as you know, displacement upon time, right? So you have to do what? Division. Division means what? Differentiation. So you have to differentiate it with respect to t. So what you will get? If you have to find out differentiation of t cube, then it will be 3t square, right? Then for 3t square, if you take 2 in coefficient, 3 times 2 is 6. You reduce 1 from the power, 2 minus 1 is 1. Then you have got t and 1. Now think it in this way. If you have to integrate this, so what you will do, sorry, we are differentiating, right? So if you have to differentiate it, what we'll do, it has 1 as power. We'll bring 1 in the coefficient form and we'll reduce 1. So what we'll get? T raised to power 0. And we know anything having power as 0 is 1. So this is 1 plus this is already 1. So if you differentiate it, can I write it like t raised to power 0? Because 1 means t raised to power 0. And you know, any variable having power 0 is 1. So I wrote t because this function is in the form of t. So t raised to power 0. Now what will happen while applying formula? You will bring this 0 in coefficient and you will reduce 1. But there is no point of solving it because 0 multiplied by anything is 0. So this is 0. Any coefficient when differentiated gives 0. any single variable, that variable itself with respect to which you are differentiating, it will be 1. Rest you know the formula, right? Now what you will do, you will put t as 0. So this is 0, 6 times 0 is 0, only 1 is left. 1 meter per second will be the answer. Similarly, if you have to find out acceleration, we know change in velocity upon time is acceleration, right? So you have to differentiate it now. So for 3 2 square, it will be 3 times 2, 6t, and we know that differentiation of that variable is 1, so 6 only. If you put t as 0, 6 meter per second square would be your acceleration. Now let's see how we can derive these three equations with the help of calculus method. So far you've got this idea that yes, acceleration is change in velocity upon time. Velocity is displacement, you can write it as s as well, displacement upon time, right? So you will use three forms in order to find out three equation of motion. So while solving this, you will bring dt into the left hand side and you can integrate. Here I would like to put forward one another point, which is limit. Let's say if you have to find out integration of x cube and limit is given to you. Limit means this x is ranging from 1 to 2. This is your lower limit, this is upper limit. So what you will do, you will solve it in the similar way. I mean by applying formula, you have to add 1 into the power and divide it with the same power. Now in the final part, you will put these limits in place of the variable. So firstly put upper limit, rest will remain same, minus lower limit. Okay, this will be your answer. So similarly, if I ask you limit for time for any motion is 0 to t, right? It can start from 0 and can lead to wherever it wants. Then for velocity, we have initial to final velocity as limit. And for displacement, we have 0 to the distance where it is leading to. Now, we are writing here 0 to t, and for this initial to final velocity. We know integration of dt will be t, 0 to t. Integration of dv will be v as per the formula. Now what will happen? You have to put this limit in place of variables. So t minus 0, upper limit minus lower limit, upper limit minus lower limit. So this is v is equals to u plus at, which is your first equation of motion, right? Now if you talk about second, what you need to do, this is v ds by dt. You can again take dt into the left. But may I ask you, this is your first equation. What is your second equation? It is s is equals to ut plus half at square. Do you have v here? No. So you have to remove v. So you can substitute u plus at instead of v here. So it will gives you a u dt, if you distribute u dt plus at dt equals ds. Now applying limit, so it will be, you have to see this variable dt, that means limit for time, again limit for time, this is limit for displacement 0 to s, right? Now for integration of dt, you have t, limit 0 to t, this is t dt. So for t, what you have got, for t dt, you will increase one power, it is t raised to power 1. So if you increase one power, so that will be t square, and you have to divide with the same and limit 0 to t. Rest integration of ds will be s, 0 to s. Now upper limit minus lower limit, upper limit minus lower limit. So you know this is 0. What is left? Ut plus half at square is equals to s, which is your second equation, right? Now you have got this v ds dt. Here something you need to remember as a trick. Now you need to find out this, right? 2as. You have to derive this form, third equation of motion. It doesn't have t, right? So we have to remove this t. What I'm doing here, I'm multiplying with dv and dividing it by dv, because it doesn't make any difference, because dv actually it will be cancelled and one is left, so we are not actually changing uh, our equation, right? So why I did so, because if you see this is v square. In integration we can have square if we will be having t dt form, v dv form, s ds form, right? So I want it to be v dv. Why? See, if you see this part, dv by dt, it is what? This acceleration, change in velocity upon time, this is acceleration, right? What is left? ds by dv, correct? You can take dv onto the left hand side, ads, right? Now, if you integrate, here limit will be u to v, because this is dv, and this will be 0 to s. So now you see v dv. So for v dv, this is having power 1. What will be the formula? 1 add divide by the same power. So v square by 2, limit u to v, and this will be integration of ds is s, 0 to s. So upper limit minus lower limit. So v square minus u square, 2 is in already there in denominator, a s minus 0. So what you have got, v square minus u square is equals to 2 will be taken to the right hand side, 2as. In this way you can find out all the three equations of motion, can derive them. Kindly apply these equations into the numericals, and if you have any doubt you can ask. I hope you understood this, and if so, then don't forget to like, share and subscribe my channel. Till my next video, take care of yourself. Bye bye.